Nothing would dim. The sun would still rise, screens would still glow, lasers would still cut through the dark. If the speed of light began to slow down, the universe wouldn't announce it, because light wouldn't stop working, it would just arrive late. At first, the delay would be microscopic, a fraction of a second, too small to notice, too small to measure directly. But the universe runs on margins. Light is not just illumination, it's information. Every signal you see, every screen you touch, every image your brain processes depends on photons arriving on time. The first place the delay would be felt wouldn't be astronomy, it would be communication. Fiber optic networks rely on light moving at a predictable speed. A slowdown, even a tiny one, would increase latency everywhere at once. Video calls would feel slightly off. Audio would desynchronize just enough to irritate, not enough to alarm. Engineers would blame traffic, then hardware, then compression. No one would suspect the universe. Your eyes would feel it next. Vision isn't passive. Your brain predicts what you're about to see before the light actually arrives. A slower light signal would widen that prediction gap. Movement would feel less sharp. Fast objects would feel harder to track. Athletes would miss by millimeters. Drivers would hesitate in split-second decisions. Again, nothing dramatic, just enough to introduce doubt. Scientific instruments would begin disagreeing. Time-of-flight measurements would drift. Calibration would require constant adjustment. Labs would notice results becoming harder to replicate across distances, not errors, inconsistencies. Astronomy would resist the conclusion the longest, because space already involves delay. Stars are seen as they were years ago, galaxies millions of years ago. A slowdown in light wouldn't change what we see, it would change how wrong our distance calculations are. Suddenly nothing would be exactly where we thought it was. Cosmic maps would stretch subtly. Objects would appear closer or farther depending on outdated assumptions. The universe wouldn't look different, it would behave different. And this is where the danger begins, because the speed of light isn't just fast, it's foundational. It's the limit that holds causality together. If that limit shifts, even slightly, every system built on timing, distance, and synchronization inherits the error. By the time scientists began suspecting light itself was slowing down, society would already be compensating. Buffers added, margins widened, expectations lowered. The universe wouldn't feel broken, it would feel delayed. The first systems to truly panic wouldn't be scientific. They would be invisible. GPS depends on light speed precision. Satellites constantly exchange signals, correcting for relativity down to nanoseconds. If light slowed even slightly, those corrections would be wrong everywhere at once. Locations wouldn't jump, they would drift. Navigation systems would feel unreliable. Planes would widen their safety margins. Autonomous vehicles would hesitate longer than necessary. Engineers would chase latency ghosts. Updates would roll out. Hardware would be replaced. Entire infrastructures would be blamed, except the one thing no one was ready to question. Physics would start arguing with itself. Einstein's equations assume a constant speed of light. Change that constant, and space-time geometry breaks. Time dilation predictions would drift. Relativistic corrections would misalign with observation. Not enough to invalidate relativity. Enough to make it feel uncomfortable. Experiments across long distances would stop agreeing. Particle physics would see timing offsets that couldn't be reconciled. Communication between observatories would introduce unexplained phase errors. Suddenly, simultaneity would become harder to define. Events that should be causally linked would feel fuzzy. Astronomy would begin rewriting distances. Redshift calculations would shift subtly. Expansion models would strain. The universe would appear to be behaving incorrectly, accelerating where it shouldn't, slowing where it should. Dark energy wouldn't be questioned. Light would, but questioning the speed of light is like questioning gravity. It's not something science is designed to do casually. Meanwhile, technology would adapt. Systems would stop relying on real-time confirmation. Predictive buffering would become standard. AI would guess what signals should be before they arrived. Accuracy would be replaced by anticipation. Human decision-making would lag behind machines even more. Not because humans became slower, but because the universe did. Markets would feel it. Milliseconds matter in finance. A universal slowdown would erase competitive edges. Trading would become less about speed, more about prediction. Volatility would increase, not from chaos, from uncertainty. And still, no one would panic, because the slowdown would be global. There would be no unaffected region to compare against. No control universe, no external clock. Every measurement tool would be built from the same slowing reality. And that's what makes the problem unsolvable. By the time consensus formed that the speed of light itself was changing, civilization would already be operating under new assumptions. The universe's speed limit wouldn't be gone. It would be unstable. And instability at the foundation doesn't stay contained. At first, nothing would explode. No stars collapsing overnight. No planets tearing themselves apart. That's the most dangerous part. Because when the speed of light becomes unstable, causality becomes optional. Cause and effect are stitched together by light. Every interaction, every force, every signal depends on information traveling at a fixed speed. Lower that speed, and the stitching loosens. Events stop lining up cleanly. A reaction might arrive after its consequence. Not dramatically, not in a way a human could feel, but in ways machines and equations would detect. Quantum systems would be the first to misbehave. Entanglement experiments would show delays where none should exist. Correlations would stretch in time. The universe would begin allowing information to hesitate between happened and about to happen. Probability clouds would thicken. Reality would start buffering. At cosmic scales, the damage would compound. Stars rely on pressure feedback to stay stable. Light carries energy outward, balancing gravity's inward pull. Slow that feedback, and stars respond too late. Fusion becomes inefficient. Stars grow slightly denser. Some would burn hotter. Others would dim without warning. Supernova models would fail spectacularly. Galaxies would stop behaving like systems and start behaving like accidents. The universe's expansion would no longer be smooth. Regions would fall out of sync. Light from distant galaxies would carry outdated information. What we see would no longer represent what is. Astronomy would become archaeology. We wouldn't observe the universe. We'd observe its memory, and memory lies. Eventually, black holes would dominate the conversation. Event horizons are defined by light speed. Change that speed and horizons shift. Information thought permanently lost might reappear, or never fully fall in. Causality loops could form. Not time travel, something worse. Regions where outcomes influence their own causes. A universe that can't decide which version of itself is correct. At that point, physics stops being predictive. It becomes historical. We wouldn't calculate the future, we'd document the aftermath. And then comes the question no one wants to ask. What if this isn't a natural failure? What if the speed of light was never a law, but a setting, a constraint, a throttle? If the universe were a simulation, adjusting the maximum information speed would be the cleanest way to manage load without crashing the system. No alarms, no shutdown, just gradual degradation, like lowering resolution to keep a game running. And if that's true, a slowdown wouldn't be a bug, it would be maintenance. The terrifying possibility isn't that the universe is breaking, it's that it's being adjusted, quietly, globally, and in a way no one inside it can ever prove. Because the moment reality slows down, so do we. For more curiosities and mysteries of the universe, like and subscribe to the channel.